have to check if this series is absolutely conditionally convergent or divergent. So the first thing that we notice that this is an alternating series, so we should check for absolute convergence, and to do that the first step is to calculate the absolute value of the general term. So the absolute value of minus 1 to the power n times 4 minus 5n over n squared minus n. And this is of course 5n minus 4 over n squared minus n. Now let's take a look at this series. So the sum of 5n minus 4 over n squared minus n. Now all the terms are positive, and we can rewrite this series like this. So it will be 5 minus 4 over n minus 1. And this behaves similarly to this series. And we know that the sum of 1 over n is divergent. This means that this series is also divergent, and from here we get that the original series is not absolutely convergent. The second thing to do is to check for conditional convergence. To do that, let's rewrite this series. So this series is nothing else but minus 1 to the power n plus 1 times 5n minus 4 over n squared minus n. And we should use the Leibniz criteria to check for conditional convergence. The first thing we need to check is whether the general term is decreasing. So let's calculate the derivative of 5x minus 4 over x squared minus x. So using the quotient rule, this is of course going to be 5 times x squared minus x minus 5x minus 4 times 2x minus 1 over x squared minus x squared. And on the top we have minus 5x squared plus 8x minus 4, and on the bottom we have the same thing, so x squared minus x squared. Because here we have minus 5 times x squared, we know that for large enough x, this is going to be negative, and the bottom is always positive. So we have negative over positive, which is negative. And because derivative is negative, we know that the general term is decreasing, so the first condition holds. The second condition is that the limit of the general term, so the limit of n minus 4 over n squared minus n, as n goes to infinity, is 0. So let's calculate this limit. Well, obviously this limit is nothing else but 5 over n minus 4 over n squared over 1 minus 1 over n. 5 over n goes to 0 if n goes to infinity, this also goes to 0, and this also goes to 0. Therefore, the limit is 0, so the second condition also holds, and this means that our series is conditionally convergent.